subscribe and press this bell icon to never miss another lecture video. Welcome to GATE ESE lecture. We are in lecture number 54 of signals and system. Here in this video lecture, from this video lecture onwards, we're going to discuss about the Fourier representation of a signal. Okay, so there is this scientist whose name was Jean Baptiste Fourier. So what he did, so he has shown that any periodic non-sinusoidal signal that can be actually expressed as a linear weighted sum of harmonically related sinusoidal signals. Okay, so basically, so I can summarize this definition in this way: a method of representing a signal in frequency domain as a linear weighted sum of harmonically related sinusoidal signals. Okay, so the linear summation of all those signals, all those terminologies whose frequencies are linearly and harmonically related with each other, and most importantly, every terminology will be in sinusoidal format. Okay, now you must be thinking कि sir ये क्या बोल रहे हो, हम लोग confuse हो रहे हैं. Okay, I'll make it clear, crystal clear. So if I clear it, like it's a very simple thing. Any signal, listen to this carefully, any signal, when you are representing any signal in a frequency domain, okay, when you are representing, the method of representing any signal in a frequency domain, that is your Fourier representation. That means in this way, Fourier representation is a method through which, or by which, Fourier representation is a method by which you can represent any signal in frequency domain. Simple. Okay, now this can be this came out to be nicely. Listen to this carefully. Fourier's representation is a method by which any signal can be represented in frequency domain. It's a very simple thing. Now, any signal, I told you, means there must be some periodic signals would be there, and there must be some non-periodic signals will be there. Yes or no? Now, the method with which periodic signals are represented in frequency domain in a linearly weighted sum of harmonically related sinusoidal signal format, that method will be known as Fourier series. I told you any signal, no? So if that signal is periodic, then that method of representation will be Fourier series. If the signal is non-periodic, then we take, listen to this carefully, we take the fundamental time period. You know na fundamental time period, first harmonic, second harmonic, ये सब कर जानते हो ना? So if my signal is a non-periodic signal, then the fundamental time period will be taken, fundamental time period t, which will be taken as t tends to infinity, which will be taken as that कि वो fundamental time period उसका t tends to infinity, तो उसका fundamental time period infinity लेके उस non-periodic signal को represent करने का तरीका को बोलते हैं Fourier transform. Clear? So any signal can be represented in terms of linear weighted sum of harmonically related sinusoidal signals. Okay, this is your Fourier representation. It's a very important, beautiful line. Please write it down, or after, whenever I'll give you the note, you can write it down. Okay. So the method of representation in frequency domain for periodic signals. So I can write down here for periodic signals, yes or no, representation, the periodic signal, for periodic signal, the method of representation, okay, the method of representation in frequency domain, this is called as Fourier series. Similarly, for non-periodic signals, the method of representation in frequency domain. Yes, in frequency domain, that will be known as Fourier transform. So how we wish to take this Fourier transform? We take first t tends to infinity, fundamental time period tends to infinity. ये आगे पहले fix करके then we do this analysis. Okay. Second point is very important. Listen to this carefully. So the third point, I can say that Fourier series can be applied to periodic signals, and your Fourier transform can be applied to non-periodic and periodic signals. Okay, so if you get some kind of assertion reason kind of question, so you can answer it properly. ऐसा नहीं है कि Fourier transform खाली periodic के लिए है, ऐसा नहीं है. Fourier transform आप non-periodic के ऊपर ही apply कर सकते हो. It's not an issue. Okay, but mostly Fourier transform is invented for non-periodic signals only. Clear this concept? But you can apply it here for both the signals. Now in frequency domain, so we are going to convert any signal from time domain to frequency domain, right? Time domain to frequency domain. Now the method of representing any signal in frequency domain, can be dependent on either magnitude versus frequency graph or phase versus frequency graph. Clear? So this is as frequency domain, all these things are in frequency domain, then that will be, this entire thing will be, this will be included in a frequency spectrum, this will be included in frequency spectrum. Mostly this is called as magnitude spectrum, and this will be called as phase spectrum. Okay, so method of representation can be divided in these two ways. Okay, so we'll get back to this once we are done with the formula thing. Then we'll get back to this concept again, this magnitude spectrum and phase spectrum. Just know that ki frequency domain representation, the way that we told you na ki hum frequency domain mein represent karenge any kind of signal ko, right? We told you na that thing. Now how you're going to represent it, how you're going to communicate with either a system or either any person, ki how you are going to tell them. You want to tell them in terms of magnitude versus frequency spectrum, or phase versus frequency spectrum, or in phase versus frequency spectrum. This is called as magnitude spectrum, this is called as phase spectrum, and this entire spectrum analysis is called frequency spectrum analysis. Now let me define the formulas to you. So first of all, the Fourier series, from this video onwards, I'm going to tell you about Fourier series. I'm going to explain each and every point on Fourier series. Now important point, after we are done with the Fourier series, then we'll get into Fourier transform. Okay, यहाँ पे I'd like to tell you a couple of very important clarity on a couple of things. First thing is that if I start analyzing each and every questions from Fourier series, it will, for each question it will going to take at least 15 minutes. For each question it will take at least 15 minutes. Okay, and every question is important, and this entire lecture will extend to around 100 hours or 150 hours, या फिर 70-80 hours तो हो जाएगा. Okay, so in order to minimize that, I did one thing, I need to share with you all the concepts, all kind of concepts, important points, important theories, every single thing I would like to share with you. But for that I need to, most of the time, so if this is your concept box, if this is the content that I have, most of the, like 85% of the content, I'm going to represent it to you. Okay, if you have any doubt on this representation, you can do the derivation by your own, because I'll provide you all kind of material. बट बाकी के जो 15% है मैं काफ़ी क्रूशियल कॉन्सेप्ट हैं वो मैं आपके सामने डिराइव करूँगा, बट 85% आई एल गोइंग टू प्रिफर द रिप्रेजेंटिंग टू यू. Okay, similarly the formula I'm not going to derive the formula. I'm preferring more and more to prepare you for GATE and engineering service exam, not for semester exam, right? So that clarity you must have in your mind कि हमको GATE और engineering service के लिए clear करना है. Yes, you need to prepare for GATE and engineering service exam, not any kind of semester kind of exam. So that is why I prefer more. So that is why I'm going to prefer to discuss more and more number of varieties of questions. ठीक है, so without wasting any time, let me tell you, Fourier series can be represented, that means a periodic signal can be represented in frequency domain in two methods, in two ways. One is in terms of trigonometric expression, one is in terms of exponential expression. So what is the trigonometric expression? Look here carefully. X of t is nothing but equals to 1 by 2 a naught